This is practice B for section 2.6. We're going to look at number 3. And we're going to look at number 4. In number 3, they tell you that the distance from A to L equals the distance from S to X. You can mark that like this if you want. You need to prove the distance from A to S equals the distance from L to K. Now, we have seen this example at least 2 other times, probably more. This was the same as the mall problem, and it was the same as the problem we just did on 2.6 practice A, the problem with the 3-day race. If these 2 lengths are the same, I'm just going to pretend they're each 5. Maybe the distance from L to S is 8. How long is it from A to S? It would be 13. How long would it be from L to K? It would be 13. They're the same. So given that these 2 are equal, we can definitely show that these 2 are equal. Now we believe it. So the only thing we have to do is prove it. And again, if you're stuck on this, probably a good strategy to do is look at those other problems that are just the same as this. You're just using different letters. So hopefully the more you see this, the better you get. Okay, first step, that's your given. They give this to you to use. How do you know a segment is the same length as itself? That's reflexive. Now, this follows from these 2 statements, and there's no way for you to know that other than just being aware of them. You might think this comes from the diagram, or maybe this comes from the given or something. If this statement 1 is true, if we add the same thing to both sides, then we get this equation. That's the addition property of equality. This statement comes from the diagram. And again, there's no way for you to know that other than to just be aware of your surroundings. Distance from A to L, that's that little segment that has a length of 5, plus distance from L to S, that's the one that has a length of 8, that equals the distance from A to S. That's the one that has a length of 13. When you add 2 little segments to get a big segment, that's your segment addition postulate. I'm pretty sure this next step is the same thing. Let's just double check. S to K, that's 5. L to S, that's 8. Altogether, does that make L to K 13? It does. That's your segment addition postulate also. Since you use the same reason, you could have smushed these 2 reasons or these 2 statements together into one step if you wanted, but sometimes that makes things more cluttered. So what's happening here? We have pause for a second while I get some colors to help. We have this yellow thing, and this yellow thing equals a pink thing. So if the yellow and the pink are the same, notice how the yellow and the pink each are equal to 2 different things. Are those 2 different things really different? They're not. They each equal a yellow and a pink, and we know yellow and a pink are the same. So those 2 things are the same as each other. That's your transitive property. And it's equality because we have equal signs. Now, if you would go back and look at your shopping mall problem or your race problem where there was something about 95 miles here and 95 miles there, if you look at the reasons in those problems, I can almost guarantee you they're exactly the same. Maybe the order's a little bit different because they stated things a little bit differently, but the same general concept is happening in all 3 of those examples. Here's number 4. This is a fill-in-the-blank proof. We're given that the measure of angle 4 is 120 degrees. I'll write that in there. They're telling you that angle 2 and angle 5 are congruent, and angle 4 and angle 5 are congruent. Okay, so if angle 4 is 120 and it's congruent to angle 5, wouldn't that make it 120? If angle 2 is congruent to angle 5 and angle 5 is 120, wouldn't that make angle 2 120? Yeah, for sure. Can you prove then that angle 2 is 120 degrees? Yeah, we just kind of showed it there. Now, we showed it for that one particular example. We need to show that this works all the time. That's what the proof is for. So here's an example where they give you 3 things and they post all 3 things in that first statement as you're given. Angle 2 and angle 4 are both congruent to angle 5. So doesn't that mean that angle 2 and angle 4 are congruent to each other? That's your transitive. It's a property of congruence because we have congruent signs. You just need to be aware of what you're saying as you're given, because you're allowed to use that, and that's what you need to come up with this answer. Well, if we have 2 congruent angles, what does that mean? Notice how they're using definition of congruent here. It means their measures are equal. And if their measures are equal, you can get this next statement. What is the measure of angle 4? They told you it's 120. So you can take this out and replace it with 120. When 2 things are equal, like you said in your proof, you can replace one with the other. That's substitution.